Welcome to lesson 15. I'm mapping chromosomes. I'm going to go through today's lesson in hopefully about 30 minutes. And then what we'll do is I'll get you guys to do some work. Let's make a start. So first things first, this is going to be a bit different because obviously we're teaching from home, and it's going to be a bit of an interesting experience. You might ask how many of these are going to be videos that you have to watch, how many of these are going to be classes where you have to do different work, how many of these are going to be Google Meets, and I'm not really 100% sure. At the moment, what my plan is to sometimes give you these kinds of lecture-based things over PowerPoint. Sometimes I'll do them via Google Meet, and then probably sometimes I'll just give you guys a video that I want you to watch instead. But there'll be something for you to do each lesson that we would normally have class. So today, you guys would have class year 10 science, period 1 and 2. We would be sitting in B9 about now, and we'd be learning stuff. But yeah, we're just going to be doing it this way. The next lesson that we have will be on Friday. So I'm going to give you guys probably something similar to this on Friday. But actually, maybe on Friday I might try and do a Google Meet. So get you guys all together. Get as many of you guys together as I can anyway. And go through a lesson that way. We'll see how they compare and which one's good and which one's not. And let's go have a look at what I've been working on. 1 second. So this is the document that I've given to everyone. What I've tried to do in this document is I'm going to use this document as just a general place to put all the information, as well as on Compass. So you can find this link on Compass. I've also put it on the Google Drive. This piece of information, by Google Drive I mean Google Classroom. So what we should see here is today's sort of term 2, week 1. And so I haven't completely finished this yet. Hopefully by the time that you are looking at this, you guys can see it a bit better. But because now this is live, I'll make it white. I'll merge all. And so we can see here, lesson 15, mapping chromosomes. That's what today's lesson is. That's what I want you to do. And this is what I want you to do after the lesson. So I'm going to come back to this page perhaps at the very, very end. One more thing that I want you guys to do, though, is I would like you guys to get onto the Google Classroom. Now, the Google Classroom, give us a second. Now all this work here will be updated as time goes on. So at the moment there is nothing here for week 2. There's nothing. There's like so on and so forth. But you guys will see that it'll go up there. And then if you have any issues, you can email me there. So let's go have a look here. So you guys are going to be doing year 10 science. Now, I haven't actually got all of you guys students involved. So if you're not involved at the moment, this is the code. I'm actually going to put this code as one of the tasks to do on the Google Classroom. In fact, I might make it the first task. So if I just go insert row above, join Google Classroom. Then I will say use the code to join the Google Classroom and answer the attendance question. the code I'll put here. I'll make this black. Yep. Link, I'll just give you guys a link. It's probably link probably won't work, but you guys know where to go. Okay, so yeah, the Google Classroom, one more thing before I move on. The Google Classroom here there should be a question for you guys to do. And the question here, so some people have already jumped on board, which I'm find really, really good. The question here is, you need to click on which one of these. Now, it's called an attendance question because now I know that these 3 students have actually been online and seen what's going on. Okay? But if you haven't done that, then I'm going to assume that you haven't actually logged into the classroom. So that's going to be what I want you guys to do. All right? Now, let's get back to the actual lesson. So today's lesson 15 is about mapping chromosomes. I'm going to skip over the previous lesson because which I would normally talk about, because I want to actually just talk about this lesson, and you can actually go back through the slides to see what we did last time. So what we're going to look at is we're going to examine mainly the differences and similarities between chromosomes and different types of chromosomes. So that means we're going to look at different types of chromosomes. I will quickly talk about the main idea of what a chromosome is if you've forgotten. So we start off with DNA. The idea with DNA is that we've got a big long string of it. And then what happens is we can take that big long string, we can take some round sort of protein ball things, we can wrap the protein around it. And if we wrap the big long DNA around the balls, we can actually get things that look like this. That is going to be a chromosome. So, okay, fine. Why do they do that? What is the advantage of it? That's what we're going to answer here. So essentially chromosomes are like moving boxes. What they do is they allow us to pack DNA really tight so they can move them easily. And I want you guys to think about this. How many boxes do we need? Like, how many boxes do we need to move like a whole body's worth of chromosomes? Okay. So, again, with a pencil like this, I want you guys to write this down. I don't know if you can write this down in your book. If you haven't got your book yet, remember you are able to go to the school this week just to pick up your supplies. If you want to just write it down on loose leaf paper though, then that's okay. That's another alternative. But what I will do is later down the track, I'll do some kind of book check. So keep that in mind. Why we pack these up is because essentially when we go from one cell dividing up into 2 cells, we need a way that we can easily move all of the DNA from one cell into like 2 small cells. Now, if there were big long strings, it'd be really, really difficult to move. Like imagine trying to move all of your clothes one by one. They would be very, very difficult. But if you could pack all your clothes into a box, then it would be a bit easier to move. So that's why these chromosomes are like moving boxes. The idea is that we can pack them all up into a box and then move them and then unpack them or untangle them. So the idea is it goes from this to this. So how many boxes do we need? Well, if you were sitting there thinking, well, I know there are 46 chromosomes in the human DNA, that means you would need 46 boxes. And that would be correct. See. That's what I mean here. So it's a bit better of a picture. In order to move from one to the other, you need 46 boxes, and then 46 boxes show up here and 46 boxes show up here. It's because the boxes duplicate. I'm going to go through why that happens later on, not today. But when we talk about splitting cells in more detail, the mitosis, meiosis things that we talked about last term, when we go through that in more detail, we'll explain that. Okay, so humans have 46 chromosomes. Let's have a look at them. So here are all of the 46 chromosomes. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so on, 46. Now, I'm going to do this for a sec. What do you notice about these chromosomes? Like, what's significant? Hopefully you guys have noticed this fact here. These two, hopefully you guys have noticed that these two here, the chromosome number 4, are roughly the same length. And these two at number 8 are roughly the same length. And there are only two that are that length, and there are only two that are this length, and there are only two that are this length. The idea is that these chromosomes come in pairs. And that's the main idea here. Okay, so let's go have a look at these pairs in a bit more detail. Humans have 46 chromosomes, and this picture is known as a karyotype of a human's DNA. So we refer to this is a new word here, karyotype. This here would be a karyotype. You might want to get your genomes karyotyped, which means you would want to get your, you want to find out what your DNA looks like when it's done like this. Okay, karyotyping or genetic testing, there are actually different websites out there that will do this for you, which is and different companies. 23andMe is one. But yeah, the idea is that you've got karyotyping is this way of organizing all of your DNA. So chromosomes, as we just said, come in pairs because one comes from the father and the other comes from the mother. Okay, so now we have a reason why. So for example, let's just choose one. Let's choose chromosome number 9. Maybe this one came from the father and this one came from the mother. You can't tell from looking at them. Obviously, you would have to genetically go through them and figure out which one's similar, but one will come from the father, one will come from the mother, and that's true for each of these. Pairs of chromosomes are called homologous, and non-homologous means they don't match. So that means, for example, these two here at number 7, they are homologous. If I can spell homologous. Now, if I took these two over here, they would be non-homologous. They are different lengths. One is much longer. One's much longer than the other. And they have different pairs, so they come from different groups. So that's why we call them non-homologous. Now, finally, we've got there are 44 of the chromosomes match exactly. So that means that of these chromosomes, 44 of them match exactly, but 2 they're called autosomes, but 2 don't always match, and they are the sex chromosomes. Let's go have a look. So here are all the autosomes. They all match perfectly, but down the bottom right here, now you can see why I hid my picture. These 2 here are called the sex chromosomes. These 2 can be different. In this case, we've got in this case down here, we have an X chromosome and a Y chromosome. They don't really look like X and Y's, so how you might want to figure it out is one is very, very long and one is very, very short. Because you've got an X and a Y, we would say that this is a male. And in this case, I can definitely say which one came from the father and the mother, because the father is the only one that can give a Y chromosome. So autosomes are, let's really quickly go through the main new types of languages here. Karyotype means all of the DNA. Homologous means two that match. Non-homologous means two that don't match. Autosomes are all of the DNA from pair 1 to pair 22, except for the sex chromosomes, which represents the last two. That really should be bolded, actually. So let's go have a look at these sex chromosomes. Okay, let's have a look at them in a bit more detail and see what we can find out about them. Okay. Alright, so the sex chromosomes. What do we know about them? So you can have two types of sex chromosomes. Double X's, that means you've got a girl. An X and a Y, that means you've got a boy. There are two types of sex chromosomes. Okay? And so the two types of sex chromosomes, the X and the Y's are much shorter than the X. What else do we know then? Well, that's exactly what I just said. If an organism receives an X and an X, they will be a female. If they receive an X and a Y, they will be a male. So we can actually see that. We can actually see that here. So we've got an X and a Y. An X and an X is going to be a female. Now, that means that a mother can only give an X X chromosome. So there is a 50-50 chance that the father will give his X chromosome, making a girl, or his father, or his Y chromosome, making a boy. And it's actually a nice picture that I like that sort of describes this. So over here, this one here is the mother. And so she's going to give either her left X or her right X. Now, you wouldn't actually refer to that as left X or right X when you were talking about it as a in genetics, but still, the idea is the kid's going to get an X from mum no matter what. But the father has an X or Y. If the child gets the X, then you've got an XX going on. You've got a baby girl, great, excellent, paint the walls pink. If they got the Y though, then that means you get an XY. You've got a male child, a baby boy, paint the walls blue. Or don't be gender stereotypes. But the idea is that one of the funny things that I've heard a lot happen is that people then go and say, it's because you can now just blame fathers for choosing the sex of a child, because a lot of times they'll say, like in the old days, kings would say, you have to provide me an heir, you have to give me a male child. But obviously, it's completely on the king's job to provide the male child, because he's the one providing the Y chromosome. So the quick idea about sex chromosomes, they're either an X or they're a Y. If you've got two X's, you're a girl. If you've got an X and a Y, you're a boy. That's it. So what happens if what are some of the problems with genetics? What are some genetic diseases, some syndromes that show up? So this is a syndrome called monosomy. Now with monosomy, that means you're missing a chromosome. Let's look at the word mono. Mono meaning one. Okay? So you're missing a chromosome. So let's go have a look here to see where that missing chromosome is. We've got 2 in number 1, 2 in number 2, and this is a karyotype here. But if we look here down at pair number 23, we can see that we're missing one. We're missing a Y chromosome. We've got one X, but we haven't got a Y. This is a karyotype. So again, this is a karyotype of a person, which is spelled wrong, with Turner syndrome. A sex chromosome is missing, leading to many complications of puberty and reproduction. Now, I'm not going to put up pictures because either A, you can look this up yourself, but essentially it just means that the people suffering this syndrome, which are usually females, lack some of the basic sexual developments that most people go through puberty, and they usually can't have children. You can miss chromosomes on different. I will quickly say though, you can miss chromosomes on different spots in the genetic sequence. Like you can miss something on your 3rd or your 10th chromosome. It just so happens I've just chosen this one to demonstrate the idea of monosomy. Okay. Is there an opposite of this? Well, there is actually. The opposite of monosomy would be trisomy. Let's go look at the idea of tri. Tri meaning 3. So that means trisomy probably means that one of our pairs has 3 instead of 2. So let's go look. 1 seems okay, 2 seems okay, 3 seems okay, all the way down until you get to 21. 21 has 1, 2, 3 instead of having 2. So that means this person actually has 47 chromosomes instead of 46. The other person would have 45 instead of 46. So this is a karyotype, is an example of someone with Down syndrome. So a lot of you probably have heard Down syndrome, where there is an extra autosome. So I've used the word autosome here because that's what it is. It's a regular chromosome, not a sex chromosome. It's an extra autosome for number 21, for pair 21. This leads to the body. This leads to body and neurological development issues. So we've got some issues that show up when we deal with trisomy. So let's put these 2 ideas together. So putting these 2 ideas together, we get the idea that monosomy means missing a chromosome. Mono means 1. Trisomy means an extra chromosome, so tri equals 3. And over here on the right, this is actually taken straight from your books, and I've actually just quickly looked at it just to see some extra information here. So we can see that extra 21, that's going to be Down syndrome. We just talked about. But there are other syndromes here as well. So if you've got an extra one on number 18, then you've got Edwards syndrome. And these here over on the right is how rare these things are. You can see that Down syndrome, 1 in 700 live birth. That seems to be happening a lot. Whereas something like 1 in every 5,000 births for Patou syndrome is kind of rare. You can get, I will quickly say, you can get an extra sex chromosome. So these are autosomal disease. So these are on the autosome. How can I tell? Because they're not sex chromosomes. Whereas the sex chromosomes, 47, 47, these are an extra sexes like XXY or XYY. Sometimes they don't have names, so this one doesn't have a name. You might have the situation where you're missing a chromosome. Here is the one that I was just referring to before, Turner syndrome. And you could have like half of that. You could be missing part of a chromosome. So maybe you're not missing the whole thing. So if you're missing part of number 4, you would call that Wolf-Hitchkin syndrome, and you've got and that doesn't affect many people. So this is missing some of a chromosome, not the whole thing. So, and that's it. So let's quickly go back over really quickly what we've done today, right? So what we've done today is we've talked about chromosomes. We said chromosomes are a way to pack up DNA so that it can be shipped around from one cell to another cell quite easily. We have 46 chromosomes, which means we need to ship 46 of them. we can group them into a group that we know as a karyotype. This is a picture of all of the chromosomes. You can have matching pairs, homologous or non-matching pairs, and most of them are called autosomes. But some of them are called sex chromosomes because they deal with picking what sex the child is. The sex chromosomes have two types. Either they are X or Y. X's, if you've got double X, you're a girl. If you've got an X and a Y, you're a boy. And obviously the mother gives one X and the father gives one either X or Y. This is also why all your chromosomes come in pairs. They come in pairs because one of these pairs comes from the mother and the other one comes from the father. We then said, well, if you have a situation where you're missing a chromosome, we call this monosomy. That means you are missing one of your chromosomes. You've only got 45. Trisomy is when you have an extra chromosome. That means you might have 47 chromosomes in total. Okay, and we quickly grab a look at this diagram here to see what was going on. What I'd like you guys to do now is, if you finish this, I would like you to now go and work on exercise 2.2. This one down here. So working on questions 1, 3, 4, 5, and 7. Now, if you can't get access to the textbook because you haven't grabbed your textbook, or you've got some issues, or you haven't got it online, let me know. I might be able to get you a digital copy of those questions. But you'll need to email me first. Anyway, thanks for listening. If you've got any problems, send me an email and I will be with you. Tune in on Friday. We'll probably do a Google Meet or a Zoom class or something to try and get students familiar. If you haven't joined the Google Classroom yet, please do that and answer the attendance question. Thank you so much.